Polynomial functions, the remainder theorem. In this video lecture, our objective, use the remainder theorem to find the remainder when we're talking about division of polynomials. We'll find the remainder from the division of polynomials. So we're going to get into, we're going to find the remainder theorem as we work through some things here. What is the remainder theorem? And then we're going to use it. Okay, we know from a previous video lecture that we can divide polynomials. And we saw in our last video lecture, a polynomial divided by a polynomial results in a quotient plus a remainder, just like we saw with numbers. A number divided by a number results in a quotient plus a remainder. And we want to focus here this time. Okay, we're going to focus on the remainder, obviously, because we're talking about the remainder theorem. Okay, so specifically, we're talking about polynomial functions, and we want to get a little specific with what it's going to look like. So let's divide a polynomial function, and we'll call that function f of x. That's going to be our dividend, and we want to divide that by a linear function. A linear function, of course, is a first-degree polynomial, x to the first power. That's our divisor. And we want the form of that linear function to be x minus c. Okay, so we're gonna call that linear function g of x, and we want that form to be that g of x is always x minus c. Okay? And then we're also going to compute the value of the f function at c and see if we see any patterns here that can help us come up with a remainder theorem. So, f of x, in example 1, f of x is equal to x squared plus 2x minus 4, a second-degree polynomial, also called a quadratic. And we're going to divide, g of x is going to be x minus 1, a first-degree polynomial, linear. Okay, and because it's x minus c, this means that c is equal to 1. Okay, x minus 1, so c is equal to 1. Let's do f of x divided by g of x. Okay, so x, and we learned, we did this long division in a previous video lecture, so we're going to do that again. X minus 1 is our divisor. X squared plus 2x minus 4 is our dividend. Okay, the leading coefficient of the divisor that goes into the leading coefficient of the dividend, x times x is x squared. X times negative 1 is negative x. Let's put parentheses around that and subtract. X squared minus x squared is 0. 2x minus a negative x is 2x plus x, which is 3x, and bring down the minus 4. Okay, we can continue. Our new dividend can be divided by x minus 1. So x goes into 3x 3 times, so plus 3. 3 times x is 3x. 3 times negative 1 is negative 3. Let's use parentheses to subtract so we don't lose any negatives. 3x minus 3x is 0. Negative 4 minus negative 3. Negative 4 plus 3 is negative 1. And let's make a note. This is our remainder. Okay, so dividend, divisor, quotient, remainder. Okay, the remainder is negative 1. Let's take a look at f of c. Well, c is 1. So what is f of 1? Okay, so let's put 1 into the f function. Okay, f of 1 means I'm going to take the input, I'm going to square it. I'm going to multiply it by 2 and add it on. And then I'm going to subtract 4 at the end. I'll put the 1 in here. And I come up with 1 plus 2 is 3. 3 minus 4 is negative 1. Same. f of 1 is negative 1, and when we did the division, the remainder was negative 1. interesting to note. Let's go to the next example. Okay, hope you can see my paper. Example 2. F of x is equal to x squared minus 3x minus 4, second degree polynomial, also called a quadratic. G of x is equal to x minus 4, a linear polynomial or a linear function. And x minus 4 means that the value of c is 4. Okay, so let's do our division. X minus 4 is the divisor. How many times does it go into x squared minus 3x minus 4, and what is the remainder? Okay, x goes into x squared x times x is x squared. X times negative 4 is negative 4x, parentheses, subtract. No x squareds, negative 3 minus negative 4, negative 3 plus negative 3x minus negative 4x, negative 3x plus 4x is a positive x. Bring down the minus 4. X minus 4 goes into x minus 4, x goes into x one time. 1 times x is x. 1 times negative 4 is negative 4. Parentheses, subtract. And that gives me a remainder of 0. Okay, again, remainder of 0. Okay, now let's check what is the value of the f function at c. Put 4 in as an input and see what the output is. So let's see here. F of 4 is equal to, well, I'm going to square 4. I'm going to subtract 3 times 4, and I'm going to subtract 4. I'm going to square 4, I think that's what I said. Okay, so 16 minus 12 minus 4 is equal to 0. Again, same thing. When I did the math, I got a remainder of 0. When I put the value of c into the function, I also got a remainder of 0. Let's do one more. We're looking for patterns. Mathematics is often about patterns. Okay, this time the f function is 2x squared minus 3x plus 1. Again, a quadratic, a second degree polynomial. The g function is x plus 2. Well, wait a second. We wanted, if we look back here, we were saying that we want to have our g function be equal to x minus c. Okay, so I'm going to rewrite that just on the side here, that x plus 2 is the same thing as x minus negative 2. So c is negative 2 here, x minus c. Okay, x minus c. We need to note that. Okay, so g of x, x plus 2, divisor goes into the dividend, 2x squared minus 3x plus 1. Okay, x goes into 2x squared 2x times. 2x times x is 2x squared. 2x times positive 2 is positive 4x. Parentheses, subtract. 0 here. Negative 3x minus 4x is negative 7x. And then bring down the 1. Okay, x goes into negative 7x, negative 7 times. Negative 7 times x is negative 7x. Negative 7 times positive 2 is negative 14. Parentheses, subtract. Negative 7x plus 7x is 0. 1 plus 14 is 15. So our remainder is 15. Okay, now let's check what is the value of the f function when I input c, okay, which is dependent upon this being x minus. So c in this case is negative 2. F of negative 2, okay, here, 2 times the input squared minus 3 times the input plus 1. Let's put negative 2 in here. And I come up with, let's see, negative 2 squared is 4. 4 times 2 is 8. Negative 3 times negative 2 is 6. 8 plus 6 is 14, plus 1 is 15. Okay, we've done 3 examples and gotten the same thing all 3 times. Okay, so let's write that down. This gives us examples that show us what the theorem of this is. Okay, so I need another piece of paper. Okay, so here's the remainder theorem. In other words, we don't have to do that division in order to find the remainder. We can just use the value of the function. Okay, let f of x be a polynomial function. Okay, if f of x is divided by x minus c, then the remainder is f of c, the value of the function at c. Okay, there's your remainder theorem. And we just saw that. Let's go back to this sheet right here. Okay, here's my f function. If I divide it by x minus 4, so c was 4, and the remainder I got of 0 was the same as if I put the 4 into the f function. And here it is again. Oops, okay. Here's the f function. I divide it by x minus negative 2, same thing as x plus 2, and the remainder I got was the same remainder as if I put negative 2 into the f function. Okay, so that gives us our remainder theorem. Now let's use it. We don't have to do the division anymore. Okay, so I think I'm on example 4. Find the remainder. So now we're just looking for the remainder. Find the remainder if f of x equals x cubed plus 3x squared plus 2x minus 1 is divided by, okay, a. Let's divide it by x minus 1. Well, if I do all the math, I'll get the answer, but I could say that this is the same as equals x minus c, so c is equal to 1, right? X minus c. So f of 1 equals, let's put 1 into the f function. We're going to cube it. We're going to add 3 times what it is squared. We're going to add 2 times it, and we're going to subtract 1. So put a 1 in here, here, and here. 1 plus 3, 4, plus 2, 5, 6, minus 1, 5. The remainder is 5. The remainder is 5. Okay, let's do another one. We'll do one more, b. How about if I divide this same function, f of x, by x plus 2? Now remember, we're dividing it by x minus c, so we want to note here, because x plus 2 is the same as x minus negative 2, c is equal to negative 2. Okay? So we can do the division. We can divide this divided by this to get a remainder, or we can put c, the value of c, into the function, and that'll give us the remainder as well. So f of negative 2, the function says to cube it, to add 3 times the square of it, to add 2 times it, and subtract 1. So negative 2, negative 2, negative 2. And I'm going to need a calculator, I think, for all this. So maybe I can do it. This is negative 8. I'll just do it by hand. This is negative 8. Yes, this is 4 times 3, so this is plus 12, minus 4, minus 1. Negative 8 plus 12 is 4, minus 4 is 0. So the answer is negative 1, I believe. This is all 0, yeah. So the remainder is negative 1. So there you have it. That's a look. That's coming up with the remainder theorem and then using the remainder theorem. In our next video lecture, we're going to talk about the factor theorem, which is going to play a role in helping us to solve polynomials.